Hi everybody. So first let me present myself. My name is Ghachoui Mourad. I am Moroccan and I'm PhD student in exoplanets between Qadi University and in Morocco and University of Liège in Belgium. My thesis topic is contribution to the detection of exoplanets orbiting nearby stars by the mission TESS. First, what is an exoplanet? An exoplanet, it's a planet, but it's in orbit around another star than our sun. So the first exoplanet detection was in 1995 by Michel Mayor and Didier Queloz, and it was the discovery that opened a new field of science known as exoplanetology. And also it was the discovery for which the two scientists Mayor and Queloz were awarded a Nobel Prize in 2019. Since then, many space missions have been launched mainly by NASA, and these missions have dramatically revolutionized the exoplanet fields. And today, we have more than 5,000 confirmed exoplanets. So, but how can we detect an exoplanet? So in fact, we have two families of detection methods, direct methods and indirect methods. But in our project, we are using only one method, which is highlighted here as the transit method. So the transit method is based simply on the eclipse phenomenon. That is, when a planet transits in front of its star, its disk occults or blocks a quantity of light coming from the star. So when measuring the quantity of light coming from the star, we will obtain a momentum drop in the luminosity of the star. So if this drop is with very determined depth, and if it occurs periodically, we will conclude that we have a planet in orbit around this star. And the period of the planets, or the orbital period of the planets, is the same as the period of that signal. So here it's very important to talk about the mission TESS. TESS is the acronym of Transiting Exoplanet Survey Satellite, which is a NASA's Explorer class space mission led by the MIT, and whose goal is the detection of thousands of exoplanets smaller than Neptune and orbiting around bright and nearby stars for easy spectroscopic investigations by the James Webb Space Telescope. So to reach this goal, the list of stars of TESS contains more than 200,000 stars in the solar neighborhood. So TESS was launched in 2018. It is in elliptical orbit with a period of 13.7 days. So it's in mean-motion resonance of 2:1 with the moon. And it is equipped for, so the TESS spacecraft is equipped with 4 cameras with a field, each with a field of view of 24 times 24 degree. So, and they are aligned in such manner to offer a total field of view of 24 times 96 degree. And the bandpass of these SD cameras is from 600 to 1000 nanometer. So TESS has observed about the whole sky, so more than 80% of the sky, and it observed the southern ecliptic hemisphere in its first year primary mission, and the second, or the northern ecliptic hemisphere, in its second year. These observations were done sector by sector, and each sector was observed for about 27 days. And as you can see here, we have the overlap between the sectors. So they are observed more than 27 days, especially the regions that are near the ecliptic poles and that were observed for about 1 year. So TESS now has revealed about 5,500 exoplanet candidates, including 1,183 terrestrial planets with a radius smaller than 4 times radius of the Earth. And today we have about 204 exoplanets that have been confirmed, and 1,469 false positives that have been identified. And we still have more than 3,800 exoplanet candidates that need to be confirmed. To do so, the TESS team has created the TESS follow-up observing program, which is referred to as FOP. So it is an observing campaign dedicated to the confirmation of or rejection of TESS object of interest, TOIs, with seeing limited ground-based photometry. So, and the TRAPPIST telescopes are among this group or this campaign. TRAPPIST is the acronym of Transiting Planets and Planetesimal Small Telescope. It's a network of 2 robotic telescopes, TRAPPIST North, installed in Okeimdan Observatory in Morocco, and TRAPPIST South in Izo La Sila Observatory in Chile. And the 2 are of a diameter of 60 centimeters and equipped with a cameras with a pixel scale of 0.65 arcsecond per pixel, which is a very good sky resolution to observe the TESS candidates. And the field of view of these CCD cameras is 20 times 20 arc minute. So here we have just 2 pictures of the 2 telescopes, TRAPPIST South and TRAPPIST North. So for our observations in the TRAPPIST program, we have observed more than 258 TESS objects of interest with TRAPPIST South. 30 or more than 30% of these candidates are terrestrial planets with radius smaller than 4 times radius of the Earth. And more than 82 or 92 TESS objects of interest with the TRAPPIST North telescope, and more than 50% of these candidates are terrestrial planets with radius smaller than 4 times radius of the Earth. So they are super-Earths or sub-Neptunes. And for our publications, for TRAPPIST South, about 5.43% of the candidates are in preparation for publication, and 7.36% have already been published. And for TRAPPIST North, we have about 18.84 are in preparation for observation, and 6.52 that have already been published. So one of the most important discoveries that in which we contributed with the TRAPPIST North and TRAPPIST South telescopes, we have TESS object of interest 1680, which is a super-Earth in orbit around a named dwarf. We have also a system of 2 exoplanets, the test of the TOI 2096 1 and 2. It's a system of super-Earth and a mini Neptune orbiting a named dwarf also. And we have the TOI 2084, which is a mini Neptune orbiting a named dwarf. We have also the TOI 1955, which is a mini Neptune orbiting a named dwarf that is a member of a triple M dwarf system located at 22 parsec. And this planet is a very special candidate for detailed spectroscopic investigations on its atmosphere with James Webb Space Telescope, according to the transmissions spectroscopic metric. And the paper is in preparation it's led by our colleague Mathilde Timmerman. So thank you for your attention. Bye.